Anthony from mycodeteacher.com, and in this lesson, I'm going to give you a basic run-through of variables in Objective-C. The first thing I want to mention is that since Objective-C is based on C, what I mean by that is Objective-C takes C and just adds object support. Variables in Objective-C are exactly the same as they are in C. So with that said, let's get into what variables are. So if you don't already know, variables are basically blocks in memory that hold some data or some piece of information. So you can use variables to pass around information in your script or your application, and these variables will exist for the duration of your application. And so again, really any information that your application requires, you can store in a variable. You can manipulate it. Here you can see that variables are, by default, they're modifiable. So if it's a number, you can add to it, subtract from it, so anything like that. Variables have names as declared by you, or titles, if you will, that are basically a direct link to the information they store. So instead of passing around the information itself, you can pass around the variable name. And so if the information stored in the variable happens to change, the variable name that stores the information can still be passed around. So basically the use of the variable name is so that when the information that the variable stores changes, you can still use that same name to pass around the information. So there are different variable types depending on what kind of information you need to store, or what kind of data you need to store in that specific variable. So some examples are int, which stores an integer, float, which can store a floating point decimal, double, which also stores a floating point decimal but is twice as large, and I'll explain what I mean by that in the next slide, bool, which stores true or false or 0 or 1, and char, which stores one character. So here is a table that displays how much memory a specific kind of variable or a specific type of variable requires. So the first at the top of the table is char, which requires 8 bits of memory. That means basically 8 on or off switches, if you will, so 8 zeros or ones. And because of the fact that it uses 8 bits, it has a range of -128 to 127. So a character is basically linked to a number when dealing with computer programming. Next we have int, which takes up 16 bits of memory, and the range of an integer is -32,768 to +32,767. The next is unsigned int, and so it basically chops off the negative numbers, or it takes the negative numbers and adds them to the range for the positive numbers. So basically you have 0 to twice what you had earlier, or twice what you had in the integer. So the range of an unsigned int is 0 to 65,535. Next is a short int, which takes up 8 bits of memory, so it has the same range as a char. Next, a long int, which takes up twice as much as a regular int, so that's 32 bits of memory. So the range is, you can see it in the table. I'm not even going to bother saying that, because you can see it has a very long range. Next is float. A float takes up 32 bits of memory, and again, so you can store decimals in float. Double also stores float, takes up twice as much as a float, and then you have long double, which uses 80 bits of memory. And you can this table does not list every type of variable, just probably the ones you'll be using the most. And you can use modifiers like unsigned, short, long on float, double, and even some other data types that aren't listed here. So, how do you declare a variable? You can see that the syntax for declaring a variable is it begins with the variable type, followed by a space, followed by the name of the variable, so the name that you assign it. That can be a very, very, very wide range of things, but not anything. Followed by a space, followed by the equal sign, followed by another space, followed by the value that is going to be stored in that variable, and followed by a semicolon. So all statements except for curly braces end in semicolons when programming in C. So here are some examples of declaring variables in C. We have here int my integer equals 6, followed by a semicolon. Char my char equals, in single quotes, A. So single quotes in C signify that you're dealing with char data type. And then another example, double my underscore double equals 87.986. So you can see there that double can store decimals. So there are some rules as to how you can name your variables. Variable names, just as a basic rule of thumb, variable names should indicate the meaning or the use of that variable. So if you have a variable that stores, let's say, the number of wheels on a bicycle, you shouldn't name it y or x. You should name it num of wheels or something along those lines. So to make programming less confusing for you, always make the variable name based on what kind of information it's storing. So here are some rules on what or how you can name variables. Variable names must contain only letters, numbers, and underscores, and must begin with an underscore or a letter. So variable name cannot begin with a number. Likewise, variable names cannot consist of, for example, a $sign or modulo or the ampersand or the asterisk. They can only contain letters, numbers, and underscores. Also, variable names cannot be plainly a C keyword. So some examples of C keywords are int, like the data type int, or function. So you can't declare a variable using the syntax int. That will return a compiler error. Some common naming protocols are ways that programmers commonly name their variables are camel casing and underscore spacing. And so camel casing is a technique in which the first word in the variable name is lowercase, and then any word after that begins with the capital. So camel casing, capital C in the word casing, and the next protocol is using underscores to space different words. So underscore followed by an actual underscore and then the word spacing. So if we wanted to apply that to the word or the words camel casing, we would do camel underscore casing, no capital C in the word casing. So both are fine. You don't even have to follow these protocols. It's just the two most common ways that programmers today name their variables. Pointers are a specific type of variable that store an address in memory of another variable. So some examples are, so let's say we had an integer named myInt, which stored the value 6. We could create another variable, and you can see that its name is myIntPointer, and the asterisk is used to tell basically the C compiler that this is a pointer to an integer variable, followed by equal sign, followed by the ampersand in front of myInt, and then myInt. So basically what we're saying is myIntPointer store the address in memory of where myInt is located. So the ampersand basically takes a variable's name and finds where it's located in memory and then returns that. So you can think of the ampersand as the address of operator. And so now again, myIntPointer, if you were to print that out to the console or look and see what that actually stores, it stores a hexadecimal location in memory to where myInt is stored. So you might be asking yourself, well, why would we ever need to use this? You won't see it in this lesson, but pointers are useful when dealing with functions in which you want to pass in a variable and actually have that variable modified. Or let's say you want to have an array with variable size that's determined during runtime. And those are, I mean, you probably don't understand exactly what I mean, so don't worry about that. Just know that pointers are locations in memory, basically. So, without further ado, let's actually get into some actual coding examples of how to create and use variables. So I'm going to use Xcode. You can use TextEdit or Notepad if you have to be using a PC. I like Xcode for one because it color codes, also because it has some very handy text editing features, like it fills in variable names based on the first few letters and stuff like that. You don't have to use Xcode, but if you are planning on following along and actually programming with me, you will need a C compiler to compile and run your program. Xcode includes a C compiler, the GCC C compiler, but you don't need Xcode to have a C compiler, so you can just Google C compiler and you'll find what you need, or you can download Xcode at developer.apple.com, and again, installing that will also install C compiler for you. So I'm going to go ahead and open Xcode here. I'm going to go to File, New File, and just create a basic C file. And so it assumes you want to create an H file, or a .h file as a header file, but I'm just going to create a .c file. So we'll name this variables, and we'll save it to the desktop. Okay, so now we have basically a blank file minus the commentary. So we have to begin with a very common statement, the include open caret studio.h file. And so the studio.h file defines a bunch of functions that are commonly used when programming with C. The one that we're going to need is the printf function. If you don't know what a function is basically a block of code that carries out some task. So you can call to a function based on its name. Some functions take variables and do something with them, or act differently depending on what information you give them. So we're going to use the printf function, and printf, based on what you pass in the parentheses when calling to it, will output some text to the console. So don't worry about this line here. Just be sure to know that all C programming begins with the execution of the main function. So just be sure to have the syntax right here, and don't worry about exactly what this means or why it needs to be there. But it does need to be there. So int main, open close parentheses, open bracket, and then here's where we're going to actually type in some code. So I'm going to give you an example of how to declare an integer variable. Int my int equals 10. So what we've done here is we've created an integer variable named my underscore int, and it stores the it stores the number 10. So we can pass around the word my int, or the variable name my int, and that is direct link to the number 10. We can also change it. So a basic arithmetic operator is the plus sign. So we can do my int equals my int plus 1. And so what that does is it takes my int and then it adds 1 to it, and then it stores that new value back into my int. So now after this line, after line 14, my int is equal to the value 11. We can also simply just directly change it. But all along, we're still using the name my underscore int. And that's the beauty of variables. So now, let's use the printf function to actually print out to the console what is stored in the variable my int. Printf, and here in quotes goes the message you want to print to the console. So, my int stores the value. Now, don't worry about exactly what I'm about to do here, but the printf function follows a very specific style of formatting. You can't just pass in my int. It'll actually print out, the word my underscore int. So to let printf know that we want to plug in a variable here in the quotes, we're going to use a % or modulo followed by a specific letter depending on what kind of variable we're printing. So for integers, you can use %d, and that tells printf that you're about to give it an integer variable. So depending on how many of these specific tokens you use, you'll have a different amount of arguments in your function call. So we have myInt stores the value colon %d followed by the ending of the quotation marks and then a comma and then the variable that we're going or that we want to be displayed in place of %d. So we could do this twice and then give it myInt again and then it'll display it twice. So the number of commas followed by variable names that you have when calling the printf function is directly correspondent with the amount of variable plugin tokens that you use in your printf formatting. And so now you need the line return 0. Don't worry about that. Basically what we're doing is we're returning the value 0, since you can see here that it says int main, and what that means is it expects to return some integer value. 0 means there's no error. So we're going to save this, and so now I'm going to open Terminal, an application that comes on all Macs, which is basically a command line for the Unix core, which is basically the technology underneath Mac OS. So first we're going to use the cd command to change to the desktop directory, because that's where I have variables.c saved. Enter. And so now we're in my desktop, and we're going to use the gcc command. Again, installing Xcode will basically allow you to do all this and take out all the back-end steps for you. So I really suggest doing that, but you don't have to. So now gcc followed by a space followed by a hyphen, an O, another space, then in quotes the name that you want the compiler to give to the executable file. So when it compiles, it's going to make a new file that is the executable file. So if you don't already know, compiling is basically taking the code that you have written in a specific file and rewriting it so that your computer can understand it. So your computer at a lower level speaks a different language than C. So we write in C, then we use a compiler to rewrite it in a language that the computer can understand so that it can actually execute the code and then run that. So we'll call this variables executable, close the quotes, and then last here we fill in the name of the file that we want to compile. So you can see here I've named it variables.c. Enter. And so now you can see on the desktop is a new file, variables executable. And so we can run this using a period, / and the name of the executable, variables executable. Okay, so here, printf printed out, my_int stores the value, :10. So now, so this is more readable and stands out a bit more, we're going to put 2 line breaks at the beginning and the end of the printf statement. Save it, recompile, and run. There you go. myInt stores the value 10. So you can see printf replaced %d with the value that's actually stored in myInt. So now let's use the float data type. Float, my floating number equals 10.5. So now instead of using %d, which means an integer, we'll use %f, my floating number. You see Xcode fills it in for me. I'm going to save, recompile, and run. So there you can see myInt stores the value 10.5. So you can see how variables work in these examples here. So I'm going to give one last example before we end the lesson, and I'm going to show you how pointers work. So I'm going to get rid of the float here, and I'm going to create a new variable that points to the address in memory in which myInt is stored. So basically, somewhere in memory, we have a box that has the identifier my_int, and in that box is the value 10. we can actually find out or store in another variable where that box is in our memory. So we're going to do int followed by an asterisk, which again tells the compiler that this next variable is going to be a pointer to an integer somewhere in memory. My int pointer equals, and again, ampersand my int. So now my int pointer stores the location in memory of where my underscore int is stored. So now we can use percent or modulo p to print out what's stored in my int pointer, which again will be a hexadecimal location or address in memory. So we'll save this, recompile, execute, and there you can see my int stores the value OXBFFFF9F8. And so this here is this is where in memory my int is stored. So to be more appropriate, we could change this to my int pointer stores the value. And so there you have it. That is where in memory, on the computer's memory, that is the location in which my int is stored. So that about wraps up our lesson on Objective-C variables. Hope you enjoyed. I'm Anthony from MyCodeTeacher.com, and I will see you next time.